Hi everyone, welcome to the fifth lesson for topic 4.1 time series analysis. So this will be our second lesson for time series analysis, so which means that by next Tuesday we'll be finished off this topic. So you realize that it's actually quite a short one when you compare to the previous topics, right? Alright, so let's look at the learning outcome of today. So today we'll be learning how to do deseasonalization, which means the second technique for smoothing the data. So we'll be looking at how to use what we have learned previously, which is the seasonal index, to deseasonalize the data. And we are going to see how are we going to use our calculator to help us to implement this process as well. Alright, so let's start with a quick recap on seasonal index. Alright, so in the previous lesson, we talked about what is defined by seasonal index and how to calculate it. So seasonal index is an index value which quantify the seasonal effect. So normally we try to do deseasonalization for the data which having a seasonal effect only, so which means like the seasonal data. So we try to quantify what is the seasonal effect on each season in the time series. So why are we doing this? Because we want to be able to compare the season to the average season by looking at the whole situation in general. So in our syllabus, how do we calculate this seasonal index? We calculate it by using the method of average percentage. Alright, so the meaning or what is that represented by the value after we find out the seasonal index is that, for example, if let's say I got the seasonal index for a particular season is 130% or 1.3 in decimal, it actually tells us that the performance for the particular season is 30% higher than the average season. Alright, so if let's say you try to put in a very simple example, if let's say we are talking about temperature in 4 different seasons, so maybe 130% will be for the season for summer. So you know that the temperature for summer is normally 30% higher than the average season. So that's the idea. So when we have 85%, 0.85 in decimal, so which means the performance of a particular season is actually 15% lower than the average season, because we know that if let's say it's the same with the average season, then it's going to be 100%, right? So 85%, when you use 100% to minus 85, then you can get 15. So which means this is going to be 15% lower. So for example, if let's say we try to talk about the temperature for autumn, then if you get the 85% for the context, then which means that the temperature of the season of autumn is normally 15% lower than the average season. Alright, so that's the idea for seasonal index. So for today's session, we are going to look at the part where how do we use this seasonal index to help us to deseasonalizing it. Alright, so let's look at today's content. Alright, so similar as moving average, deseasonalization is actually a form of smoothing as well. So which means that we try to implement this onto the seasonal data that we have in time series. So why are we doing that? Is to remove the seasonal effect of the data. So deseasonalization is also called as seasonal adjustment. So seasonal adjustment. So which means that you try to adjust the raw value that you have by using the respective seasonal index. Alright, so which means that if let's say the question asks you to deseasonalize the data, it's the same thing when they say that seasonally adjust the data, or the data that we get after we do deseasonalization is called as deseasonalized data. And then in this term, then it can also be called as seasonally adjusted data. They are just the same thing. So how can we do that in exact? So to deseasonalize the data, we need to divide each of the value by using the corresponding seasonal index. So which means that we can try to write down a formula here. So the deseasonalized value will be equal to the raw data that we have, so meaning the raw value that is given in the question, and then divide by the seasonal index. So this is why you need to learn how to calculate seasonal index first before we move on to deseasonalization. So this is the only thing that we will use today. So after we deseasonalize the data, right, we are going to use it so that we can calculate what is the regression equation. So this part, we're going back to our first chapter, which we learned in Unit 3.1 bivariate data analysis. So you are going to do something that is like pretty similar. So the resulting data can be used to calculate the regression model or to calculate the regression equation. Sorry, I'll try to put a longer space for you guys. So why are we putting in the regression equation is that we want to see what is the long-term trend for this time series data. So after we feed the data into a regression model, then we'll be able to do prediction by using the set of data. So this is basically why we are investigating the time series data. Basically, you have one variable that changed accordingly with time. So you want to see like what happened in future, or if let's say you lost data within the time range that you want, then you want to predict what is the value at that time, then this is why we are doing this. Alright, so now we'll be looking at the same example that we used previously for the seasonal index, and we are going to do deseasonalization. Alright, so this is the exact same example that we have used previously about the number of visitors in a particular tourist attraction, so I'm not going to repeat the question again. So from the previous lesson, we have learned how to find the seasonal index, and this is the results that we get. Alright, so now we are just going to deseasonalize the raw data by using the seasonal index that we have. Okay, so the idea is very easy. What we need to do is basically divide the raw data by using the respective seasonal index. So how do you find the respective seasonal index is basically by looking at, for example, this 45,000 is refers to the number of visitors during the first 4 months for the year 2011. So the seasonal index that is aligned to this number, it will be during the first 4 months. So you will be looking at the seasonal index for the first 4 months, then you will be dividing it at. So remember that when you are doing division, your seasonal index must be in decimal. So which means that when we are trying to find this, then it will be equal to 45 divided by 1.2384. Okay, so remember for your seasonal index, when you use it to deseasonalize it, or in future we are going to use it to seasonalize it, you are using the decimal rather than the percentage. So in this row, we are writing the number for the deseasonalized number of visitor. Deseasonalize. Alright, and it's going to be in the unit for 1000 as well. So same thing here, the other name that you can try to put is seasonally adjusted visitor. They are just the same thing. But no worries about the title. So normally in your exam, you'll be just, the question will just require you to find like 1, 2, 3, like any value inside the table rather than want you to find the whole list. Okay, so this is the idea where you learn how to find everything. Okay, so when we do division, then you will be able to get like 36.337. So in this case, we are writing in 3 dp because this is like 1000, right? So which means that you can assume that you are moving like 3 places to the back. But same thing, no worries in the exam, because in the exam, normally you will have other values shown. So how do you decide how many decimal places that you need to write? Then you just follow the table that is given. So which means that if the table give you like they try to round it into 2 dp, then you are just writing down to 2 dp. If the question table give you like 1 dp, then you are just following to do 1 dp. Alright, so make sure that everything that you are doing is just consistent to what is given in the table in your exam. Alright, then for second value is for during the second 4 months, right? So that's why the seasonal index will be 79.46. So remember to change it to decimal. So which means 26 divide by 0.7946. So from here, then you'll be able to get 32.721. I think it's pretty straightforward, right? So during the third 4 month, then you are looking at the seasonal index during the third 4 month. So which means that it will be 34 and then divide by the decimal 0.9670. So from here, then you will be able to get 35.160. So that's basically the idea. So when you move on, then it's just the same thing. So 52 will be dividing by the season index for the first 4 months as well. So divide by 1.2384 and so on. So this is how you get all the answer here. Okay, so for now, I'm going to show you how can we use our calculator to do this. So remember that for seasonal index, normally you will try to do manual calculation because it will be quite time consuming and it's not actually that convenient if you want to use your TI Inspire to do that. But for deseasonalization, you can do that. So let's try to see how can we use our calculator to make the process a little bit faster and easier. Alright, so same thing, will be key in the raw data first. So add list and spreadsheet. Alright, then look at the data. Now let's use some time to key in the data that we have. So this is, let's put it as visitor. Okay, then I'm going to key in the value. So we have, oops, I'm sorry, I left out the timeline here. So this should be the time that we have. Okay, so first 4 months, second 4 months. So remember, the calculator only recognize numbers. So we are just going to put in, you have 10 values, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so that's basically our T here. Then after that, when we move on to the number of visitor, okay, so we'll be putting in 45, 26, 34, 52, 37, 42, 64, 41, 50, and then 69. Alright, so now we know that when we are finding out the deseasonalized value, what do we need to do is to divide the respective seasonal index. So we need to key in our seasonal index in our calculator. Okay, so it will be depending on you, how do you want to do this. So one alternative is you want to do it manually. So for example, this is our data after, okay, I'm just going to put deseasonalized. So I'm just putting DS. All right. So what you can try to do here is equal to, then what you can do is you are trying to divide this number to this number, am I right? So that's why 45 is your B1. So the cell B1 will divide with 1.2384. Okay, then you can check is that the same answer that you get, then you know that that's correct. Then when you move on, then which means the next one will be equal to is a cell for B2, column 2 and then row 2. So B2 is going to be divide the value for 0.7946. Alright, then after you press enter, then same thing, you check your answer is correct. Okay, then you can move on to the third one. So in this case, we have cell for B3, row B, column 3. Column B, row 3. Then B3 will be same thing, dividing by 0.9670. So equal to, then you'll be able to get the answer. Okay, so after you have carried out this thing, then you know that the continuous one will be the same cycle, right? So for example, when you move on to the fourth data, it's basically repeating the seasonal index for first 4 months. When you go to the fifth one, it's going to repeating the seasonal index for second 4 months and so on. So all these value are going to divide by the same value that you have done to the first 3 cell here. So how can we proceed with that? You just same thing. Okay, what you can try to do is make your highlighted box at C1. Alright, then after that you press shift, then after that go down. I think in your handheld, right, you can actually keep on pressing the shift, then you just press down, the calculator will straight away do it for you. But in my case here, maybe I'll need to shift down. Okay, then basically you will highlighting everything here. Then what do you need to do? Same thing, menu, fill up the data. So menu, data, fill. Then after that, just keep on going down. So go down until the data you want. So remember, although data 10, the 10th data is not we are not taking that into our consideration when we calculate the seasonal index. But when we do deseasonalized data, you still can use it to divide by your seasonal index for the first 4 months so that you can get the answer. So which means you just proceed everything until the end of your data. Okay, so fill everything, then you just press enter. Okay, so something will be helpful for you to check is you can try to look at the value here. Then just check, is this value correct? You are going to use B4 divided by 1.2384, right? So that's why that's correct. So this is B5. So the fifth value is going to be the second 4 months. So you are using 0.7946, right? So that's why this is correct. So you just check it out. So go through everything, make sure that everything is dividing correctly. Alright, then this is how you can do it in a slightly faster way. But then this is basically for the case where you have a lot of data, then you are actually finding out or calculating the answer for the whole list. Then this will be helpful because you do not need to repeat the steps that you are doing. But basically in your exam, if let's say you are just finding one or two value, right, it will be kind of wasting your time if let's say you want to key in all the value just for the idea to find like one or two value. So in that case, it will be easier that you just use your scientific calculator to get your answer. Alright, so that's the first idea that you can try to do. Alternatively, you can try to do this, but if let's say you know how to do this, I don't recommend that, but basically the idea is the same. But what are we doing now is just assigning the value into the calculator first. Okay, so which means that it's okay, I'm just going to show you here, but it will be depending on you. For me, I think this is easier. Okay, so the alternative is, let me try to delete all this first. Okay, the alternative is you try to key in your seasonal index respectively first. So this is my SI seasonal index, and this is the value for me to do deseasonalization. Okay, so what I will be doing is to key in my seasonal index first. So this is for my first one, so 1.2384. Alright, then I'll move on to the second one, 0.7946. And the next one, 0.9670. Okay, so after I put this in, then later I know that what I'll be doing is using this cell to divide by this cell and to get my answer. Am I right? So for the following data, they will be having a repeating seasonal index. So what I can do so that I do not need to continue to key in the values for all this is to copy paste. So how can you do that? Same thing, go to highlight this cell, then after that shift, then go down. Okay, oops, I'm sorry, shift down. So after you have highlight this, then what you can press is the same thing like how you do copy paste in your computer. So Control C. So you have copied this. I'm sorry, where's C? Okay, so this is C. So you press Control C. Then after that, go to the cell that you want. So which means here you are going to paste it, right? So the same thing, Control V. So you will be able to see all the value is being pasted. Alright, then the same thing, you can go on to the next one. So you are going to repeat the same cycle for the same seasonal index as well, right? So that's why same thing, Control V. Okay, then for last one, if let's say you do not want your data to be like misaligned, then just key in 1.2384. It's just one more, right? Okay, so this is the alternative that you can do. Okay, so after you do this, then the same thing, equal to. So for this cell, you are going to divide by this cell. So that's why B1, oops, sorry for that, B1, and then divide by C1. Alright, then you just enter, then you'll be able to get the answer. So when you move on to the next one, then you doesn't really need to repeat it again. So you straight away menu, data, fill, then go down until the bottom of your data. Then you'll realize that the answer that you get is the same thing as what you get in your calculator or by using the first method just now. Alright, they are basically the same thing. It just depends on which approach that you want to use. So no matter which one that you are using, I'll always encourage you to, after you use menu data fill, right, always just go down, like roughly go through that, make sure that everything that you are doing here, when you try to look at the formula that's shown at the bottom here, make sure that everything is, the calculator is running based on what you are thinking in your mind. because sometimes when you try to key in, then after that the calculator doesn't run as what you think. So you will need to every time make sure that you try to check through everything lah, make sure everything is correct then before you copy down your answer. All right, so now let's spend some time to just write down our answer in the cell here. Okay, so 35.160. So I don't think you need to, yeah, if let's say you still want to write it down, then you can just still write down something. If let's say you're scared that you forget how to calculate all this in future, then you can just try to write down randomly for some value lah. Okay, 37. All right, so I'm going to fast forward this process. Alright, so that's basically all the value that you have find for this table. So now we'll proceed for the last page of the notes, which I want to do some explanation. Why are we doing this? Then let's try to do comparison in the scatter graph that we have from our calculator. Alright, so the first thing that we'll be doing is try to create a time series plot in our calculator. So we want to see what's the difference between, what's the difference before and after we conduct deseasonalization onto the data. Okay, so same thing. So we need to add in another new page. All right, data and statistic. Then we try to change it here. Okay, so the first thing, let's try to look at the original graph first. So I think you are actually quite familiar with this graph already. We have actually looked at it since we studied, moving average then up to the previous lesson. Okay, so same thing, just plot type, then we add in the line. All right, so this is the graph that we have for this question. Okay, so now what do we need to do is we try to add in another variable in our y here so that we try to compare what's the difference after we deseasonalize the data. Okay, so menu, so plot properties, then after that add in the y variable. Okay, so add y variable, then the calculator will show you like this. Then we just input, we are entering, we want to see the difference after we deseasonalize the data. All right, so you can see the yellow color is the data that you get after you deseasonalize the data. Okay, so the first thing that you would observe is that after you deseasonalize the data, the line that you are having here is less fluctuated when you try to compare to the raw data that you have. Then after that, it is it looks much more like a straight line when you try to compare the previous data. Okay, so I'm going to explain further for the data that you have. Okay, for example, you can see, right, for the first value, okay, maybe let us try to draw the data in our graph here, then it will be easier for my explanation. Okay, so for the first one, the raw data is 45. Then after you deseasonalize it, you're getting 36, so which is lower than that. So this point is like 36. So let's try to plot it here. So 36 will be somewhere here maybe. All right, then the second one, after you deseasonalize it, then you get a value that is 2 than 32, so 32.7. So 32 is higher than the original value. So 32 maybe somewhere here. Okay, then you move on to the next one, it will be 35. So it's slightly higher than the original data. Okay, so what can you realize is that you can observe that what happened previously when we try to deseasonalize the data is that if let's say you have a seasonal index that is a number that is more than 1, after you use your raw data to divide by the number, you will eventually get a smaller value. Am I right? So in the other way, if let's say you have a seasonal index that is less than 1, and when you try to use your raw data divide by a number that's less than 1, you will get a bigger number. So you can see that 32 is bigger than 26. So 36 is smaller than 45. Okay, why is this happening? Because you can also try to imagine, why are we doing this deseasonalization is actually to remove the seasonal effect. So if let's say the change of the data will be like flattened, the line that we have is going to be less fluctuated, then which means that what are we going to do is actually bring the high points lower and we try to bring the lower point higher. So everything that you will have is like flattened. You can see, right? I mean, the difference here is that the high points are bring lower. So the low point are brought higher, then slightly higher, then the high point brought lower again, then higher, lower, higher. So this is how you can try to flatten the time series plot that you have in your graph. Okay, so you can observe that as a result of dividing a number which having a seasonal index which is more than 1, the value that below the average, okay, so which means this is the the value that above the average will be brought lower after deseasonalization. All right, so for example, this one, because the season index here is at 1.2384. So we achieve our target here, which we want to flatten the line. We want to remove the seasonal effect, right? Okay, then after that, for the next one, if let's say you try to divide a seasonal index that is lesser than 1, for example, this case, you divide by 0.7946. So after you divide by a number that's lesser than 1, then the value below the average will be brought higher after deseasonalization. So as an outcome, when you try to compare the time series plot in the calculator, the deseasonalized data is going to be having a straighter line, and also is going to have lesser fluctuation when you try to compare to the original data. So this is how this thing work. Okay, so which in another words, right, you can try to imagine it like this. Okay, when we talk about having a seasonal index that is more than 100%, which is more than 1, which means that number normally perform above the average. Am I right? So what we are trying to do is we try to remove the effect that caused by the season itself that makes the number become above the performance, above the average performance. So that's why we try to divide it and try to make it lower. So this is the time where you are having a lower performance, so which means the performance that you're having is lower the average. So we want to be able to compare everything on the same page. So that's why after we try to divide the season index, we are actually bringing that up because the lower performance is caused by the season itself. So we try to remove the effect that caused by the season. All right, so I'm going to repeat this again when we talk about prediction in our last chapter. Then I'll try to talk about everything in one shot. But basically, you can remember what are we trying to do here so that you have a better understanding in future. But basically, what do you need to remember for today's lesson is how to do deseasonalization and what happened after you carry out deseasonalization. That's basically the part. So for the part where you understand the big picture, I'm going to repeat that again in our last lesson. Okay, so no worries about the understanding part. Okay, so yeah, that's pretty much of the thing that we need to cover today. So this is just some short notes before we move on to our last lesson for next Tuesday. So if you can recall this table or this flow chart, right, then you can remember that previously we said that the data that we are dealing with normally are seasonal data. All right, so that's the difference between time series data and also the bivariate data analysis that we are trying to do. Then after that, from the seasonal data, then what are we actually finding is to want to see that what is the underlying trend in this type of data. So instead of using the raw data that we are having, so which means that instead of using the seasonal data, what we are doing here so far in these 3 lessons is to actually doing a procedure called as smoothing. So we have learned the first one, which is how to smooth the data by doing moving average. Then the second one, how do we do smoothing by using deseasonalization. Okay, so which means that always remember, if we were to continue for the analysis by fitting in the value into the regression model, you will be always using the value after you smooth the data. Okay, so you can try to write it down here. So you will not be using never use raw data. So which means you never straight away feed in your data by using your raw seasonal data that you have. Okay, never use raw data. Alright, so that will be the idea. So normally in the question, sometimes you'll see moving average and deseasonalization together, but normally question itself, they will ask you like separately lah. They wouldn't be like compile everything together, then regression for this one, regression for the other one. So normally it's something that is quite straightforward for you. Okay, so this is basically what we have covered so far. Then for the next lesson, which means our last lesson, we are going to talk about fitting the regression model, then how to do prediction after that. It's going to be quite easy also. It's basically the same thing like how we fit regression model into bivariate data, but it's just that instead of fitting our raw data, we are fitting in the data after we carry out smoothing. Okay, so that's the idea. So after the last lesson, I'm going to repeat the whole picture again. So you will find it easier to understand that why do you need to do this whole process before you can fit in the regression model. All right, then after we find the prediction, then we need to take into the consideration of the seasonal index again. Then from there will be some some extra works that you need to do lah. All right, so last part before we end here. So just to let you know what's the difference between like these two. So deseasonalization, something that is good. You can say it's good, or you can say it's a little bit advantage for deseasonalization is deseasonalization allow us to keep the number of raw data that we have. Because you can see after you do deseasonalization, right, previously the raw data you're having 10 data. So after you carry out deseasonalization, it's going to be 10 data as well. So the number of data points is not reduced. But then in moving average, right, if you can recall the method, then you know that some of the data point will be lost because we do not have the number before or the point after, right? Because normally, okay, for example, if let's say we have A, B, C, D, E, F, K. So in this easy case, if you remember, right, if let's say you want to do moving average, so if let's say 3-point moving average, so what we'll be doing is finding the average for the first 3 point, and this will be our first value. Then find the other 3, then this is our second value, third value, fourth value. So the last one will be blank as well, right? Because the last one is from DEF. So you can see that the data that you have after you carry out smoothing actually left with only 4 when you compare to the raw data, which instead you actually have 6. So that's like some kind of disadvantage for moving average because it will reduce the number of data points that you are having. And in statistic, we know that if let's say we have more data, then which means that the analysis that we are trying to do is going to be much more accurate if let's say you have lesser data. Okay, so yeah, you can get the idea, right? For example, if let's say I want to find what is the height for the average height for teenagers of 18 years old. If let's say I only get a sample of 5 people, then the other experiment I try to get a sample of 500 people, then obviously the one with 500 people is going to be much more accurate than the one having 5 people. Okay, so this is like some of the disadvantage so-called for moving average because you will reduce the data point, which means the sample that you are having is going to be reduced lah. Alright, but this is like just extra notes for you. It's actually not so significant in the idea to answer the question in your exam because normally the set of the question or the approach that you need to do will be given from the question. So if the question want you to do moving average, it will tell you. If the question want you to do deseasonalization, then they will tell you as well. Alright, but this is something that you need to keep in mind. Now, for example, if let's say we are going to do investigation in future, then that's something that we need to take note of. Alright, so that's basically for this second last lesson. Then after that, we'll be finished off this chapter by next week. Then yeah, so I'll see you. Remember to go through the study plan that I try to write in the post, so you understand that how our lesson will be going before our semester exam. Then from there, try to make some preparation, some mental preparation, and your make sure that you're arranging your time well as well lah. So take care and stay safe. So I'll see you next week for consultation. All right, thank you.